Yeah, in the previous problem, it has to be a. I stay corrected. Okay, so you understood about all this thing. Now we shall just extend it to greater than or equal to 0, right? So the previous problem was about greater than or equal to 1, where the minimal string is ABC and we have constructed the diagram, but now here it is greater than or equal to 0. Therefore n, m and l, they can even be, each one can be 0 or everything can be 0. If I put 0 in place of n, m and l, it is going to be epsilon. So the language may even contain epsilon, and if I put zeros in m and l, the language can be a or aa or aaa, so on. If I put 0 here and 0 here, it can be b, bb, so on. If I put these two to be zeros, then it can be c, cc, so on, so on. Or it can even be a combination of any number of a's followed by any number of b's, or any number of a's followed by any number of c's, or any number of a's followed by any number of b's followed by any number of c's. So the language is infinite. So all the combinations are possible. Here only thing is, if you observe it, we should not get a after a b, and we should not get a or b after a c. That is the only condition. Once if you have seen b, you should not see c. Once if you have seen c, you should not see a or b. So I have to accept epsilon. The only way in which a DFA can accept epsilon is if the initial state is final state, isn't it? Then any number of a's, I'll accept it. On seeing 1b, I will remember that I have seen 1b, and I'll accept that b, and I'll see any number of b's, and once I reach this state, I will not accept any a, or I'll kill all the strings if I get any a. And after this, I can get a c, and I will accept all the c's in this state. And once I reach this state, after seeing a c, I will not see any a or b. Now is this a DFA? It is not a DFA because it is not complete. What is the sigma? A comma b comma c. For state A, we have shown what happens on A as well as what happens on B, but we didn't show what happens on C. What if I get a C here? If I get a C here, it is nothing but directly starting with C. I should accept it, as well as I should remember that I have seen a C and I should not see A or B. Therefore, I will not accept C's staying in this state. I will accept C's staying in this state, so that once if I get A or B, I can reject it, right? So A's I'll accept it, B's I'll accept it, C's I'll go there and I'll accept it. And a string can start with A or B or C, no problem. See, string can start with A or B or C. Therefore, it is not acting as a traffic diversion. Okay. Now, next one. If I reach this state, it means that I have seen at least one B. After seeing at least one B, I should not see any A's. If I see any A's, I am going to kill that string. I don't care what comes after it. If I see any A's, I am going to kill it, right? And after B and C, if I am in state C, I can see A or B. If I see A or B, after seeing a C, I have to kill it. This is a complete DFA. See this? First state A, I have shown what happens on A, what happens on B, what happens on C. First state B, I have shown what happens on A, what happens on B, what happens on C. First state C, I have shown what happens on A, B and what happens on C. For this dead state, I have shown you what happens on A, B, C. This is the dead state. This is the answer.